This is us. One blue dot. For centuries, we have questioned.
What's the most fundamental element of the matter structure?
Where is it coming from? What's the beginning?
Why there are so much more matter than the antimatter in our universe?
So far, the question is not yet answered clearly.
I'm very curious. I want to know. I want to learn about things. I want to answer.
These questions have inspired generations of particle physicists to discover and push the limits of science. In 1950, China became part of this endeavor. Since then, at the Institute of High Energy Physics, her most brilliant scientists have dedicated their lives to this journey. With thousands of scientists and researchers, IHAP has been pushing the boundaries of particle and astrophysics.
Particle physics is the field that is trying to answer the most fundamental question about what everything is made of.
Our focus are in two directions. One is we try to understand the physics beyond the standard model. Secondly, we try to understand the universe by looking for X-rays and also the cosmic rays, so that we can understand the extreme phenomena in the universe.
To study these fundamental units of the universe, IHAP has put a lot of effort into state-of-the-art facilities, such as the Beijing Electron-Positron Collider at the heart of China, which discovered a new particle. The Large High-Altitude Air Shower Observatory and the Hard X-ray Modulation Telescope were created to detect cosmic rays further than we can ever imagine. In Dongguan, IHAP built the first pulsed neutron spallation source in developing countries to study the microstructure of materials. The Daya Bay Reactor Neutrino Experiment, built in Shenzhen, provides new insights into the behaviors of neutrinos. One of the most abundant particles in the universe, and one that's likely responsible for making us.
Those important discoveries opens a new area for studying neutrino physics.
The experiments led by this institute has already contributed many great results, ending up in the textbook of particle physics.
But still, we have unknowns, puzzles, and difficulties. To do a better research, we need both theoretical ideas and also the tools.
For a better tomorrow, IHAP has been investing in new mega science facilities. To study extreme tiny particles found in our everyday life environment, IHAP is now digging 700 meters under the surface to build the Jiangmen Underground Neutrino Observatory. By 2025, high-energy photon source in northern Beijing will finally be operational.
红木辐射在21世纪给很多的诺贝尔化学奖做出了很大的贡献，因为很多结构解析就是在红木辐射上获得的。这些前沿的科学研究，只有是一个很强大的这样一个光源，才能够满足要求的。
To study the Higgs particle, the most important subject in particle physics, IHAP has planned the Circular Electron-Positron Collider that would create Higgs particles for research. These infrastructures are made by China, but for the rest of the world. Because at the heart of IHAP is a belief that particle physics research should be accessible to everyone.
This special facility will be for the whole community. With people from outside together with people from China, we're going to run together this big project.
We want international people to collaborate with us, and I think this is happening now, is growing.
我相信，科学前沿的研究，特别是像粒子物理这样的大科学的国际合作，是它的基本的规律，是任何力量都无法阻挡。
Great endeavor takes effort, time, and most importantly, friends. While the journey ahead is long and arduous, the mission is clear.
我们不一定希望我们自己的名字能够被大家所记住，但我们希望能够为全世界的科学研究呢提供重要的帮助。
Pursuing answers about nature is something that a civilization required. And that's very important and very high level as well.
What we are doing right now may not find applications today, but it will be useful in the future.
So my hope is that IHAP will eventually become one of the leading laboratories in the world.
With an open and inquisitive mind, the Institute of High Energy Physics may one day answer the toughest questions about time, dimensions, and how everything begins and ends.